Calendars. This presentation is brought to you by Workshop Team 8, Adrian, Christian, Eric and Lucy. Throughout this presentation, you will be made aware of the complex and often overlooked makings of the Gregorian calendar and the difficult reality of trying to design a rigid structure, that is the calendar, from a constantly changing universe. Leap years. As many of you already know, a year is not exactly 365 days long. 1 year is in fact almost exactly 365 days, 5 hours, 48 minutes, 45 seconds, and 138 milliseconds long. This equates to 365.24219 days long. This is why leap years are necessary, to catch up to this extra time. If every year was 365 days, after 4 years, our seasons would shift by 1 day. After 28 years, this would shift our calendar out by 1 whole week. In the year 46 BCE, Julius Caesar, the Roman Emperor, attempted to fix this 1-day drift by adding an extra day every 4 years. This became the Julian calendar. The Julian calendar, however, presumed that 1 year took 365.25 days. This is not the case, and as a result, this new calendar led to a calendar shift of 1 day every 128 years instead. The Julian calendar needed some further tweaking. The shift from the Julian to the Gregorian. By the 16th century, the effect of this slightly off calendar was beginning to be noticed. By now, the Julian calendar was out by 10 days. To fix the calendar not precisely detailing seasonal changes, and in order to move the date for the celebration of Easter more to when it was originally celebrated, Pope Gregory XIII in 1582 decided that enough was enough. Mathematicians were hired, and it was discovered that 3 extra leap days every 400 years was necessary to correct this error. Rather than just a leap year every 4 years, leap years were not counted when the year was a multiple of 100. But were counted when the year was a multiple of 400. For example, the years 1800 and 1900 were not leap years, but the year 2000 was a leap year. The Gregorian calendar made the average year length 365.2425 days, which is much closer to the actual length of a year than what the Julian calendar presumed. Day drift is still a problem, however, but a 1-day drift will only occur every 3,216 years, much better than the previous with the Julian calendar of 1 day every 128 years. Critiques and potential solutions to the Gregorian calendar. There are, however, several drawbacks to the Gregorian calendar, some which we take for granted as unavoidable consequences of trying to design a calendar. These include the way in which each week, year, and month will start on a different day of the week, the way months are not equal in length, and also the disconnect between lunar phases and the month cycle. The world calendar, a potential solution to these problems with the Gregorian calendar, is a 12-month calendar divided into quarters. It is also perennial, as each quarter starts on a Sunday and finishes on a Saturday. Each quarter has exactly 91 days, or 3 months, with the first month of the quarter consisting of 31 days, and the following 2 months consisting of 30 days. Leap days would still be used to correct calendar drift, but would be known as world days instead. This world calendar was faced with religious opposition when it was first conceived, but still remains a plausible solution to the Gregorian calendar. It is considered one of the top contenders to replace the Gregorian calendar if it were to ever be discontinued. Thank you everyone for listening to our presentation. Hopefully you have all learned a thing or two about calendars.